Okay, so today we're going to talk about section 2.3, the remainder and the factor theorems. So suppose you have a polynomial function that looks like this. And suppose we also know that f has a 0 at x equals 3. All right, if there is a 0 at x equals 3, like we talked about in the previous lesson, then x minus 3 is a factor. All right, we also know that the degree here is x cubed. So if x minus 3 is a factor, that means we need to multiply it with an additional x squared polynomial in order to get the x cubed. So we also know that in addition to the x minus 3 factor, there is another second degree polynomial, and we'll call that q of x, that is also a factor. So meaning f of x can now be broken down into x minus 3 times this q of x. This is linear, this is quadratic, together it's x cubed. All right, so if f of x is x minus 3 times qx, well, how are we going to get qx? Well, one thing we can do is divide by x minus 3 on both sides. So we get that qx is f of x over x minus 3. All right, so let's move on to long division. I know we've covered this before. We can divide polynomials using long division or synthetic division. So what do we mean by polynomial division? So if you have f of x over d of x, when we divide, we get q of x, that's our quotient, and we get the remainder, which we always wrote as the remainder over d, right? Over what we initially divided by. Now, another way of writing it, which might be more beneficial to us, basically, if I, just multiply d of x on all sides, then it'll be f of x is d of x times q of x plus r of x. All right, let's do a couple and we'll see what this means. All right, so let's do our first example of long division. Now, it says that x minus 3 is a factor of this polynomial. All right, so let's talk about what factors mean. So if I have the number 24 and I know that 8 is a factor, I know that if I divide 24 by 8, I'm going to get a remainder of 0. So let's just start dividing this and see if we are going to get a remainder of 0. All right, so we have x minus 3 out here. And in here, I have the polynomial. And we make sure that we have all the exponents represented. The highest one is 3, then 2, then 1, then 0. We're good. So 6x cubed minus 25x squared plus 18x plus 9. All right, the process is this. The first term over the first term gives me 6x squared, and that's the number that comes here. Now, I multiply 6x squared by this entire binomial, so 6x squared times x, 6x cubed, 6x squared times negative 3, negative 18x squared. Next, I need to subtract. All right, if I subtract, my signs automatically change. So 6x cubed minus 6x cubed goes away as it must. Here I have negative 7x squared. All right, so negative 7x squared. And I bring down the 18x, so positive 18x. And the process starts all over again. So now I have negative 7x squared over x is negative 7x. So here I have negative 7x. Now I multiply. I get negative 7x squared plus 21x. Now I'm going to subtract. So subtract is also the same as change the sign and add. That's why I do that. Those go away. And here I have negative 3x. So one more time, I bring down the 9 this time. Negative 3x divided by x is negative 3 this time. When I multiply, I get negative 3x plus 9, and I get a remainder of 0, which is exactly what I expected. All right, so what does that mean? Let's write it in this format. F of x, which is 6x cubed minus 25x squared plus 18x plus 9. Now, of course, we don't have to write that all the time. We could just write f of x. I'm doing it for the first time. So f of x is equal to d of x. That's the first factor that we divided with, x minus 3, times the quotient plus the remainder, and in this case is 0. Okay? All right, so that's my answer. Now, let's go back to the problem, and it says use long division to factor f of x completely, given that this is a factor. So I used x minus 3 to break this complicated polynomial into a linear and a quadratic factor. Now I can move on and I can factor this further. So I have x minus 3 times, and now I need to factor this. And I get 3x and 2x plus 1 minus 3. Okay? So here I get negative 9x plus 2x, and there we go. This is my f of x finally. Okay? All right, let's move on. Here's another one. So factor this, given that 2x minus 5 is a factor. 2x minus 5 comes out here. And I have 6x cubed plus 17x squared minus 104x plus 60. And now 6x cubed over 2x is 3x squared. And I multiply, and I get 6x cubed minus 15x squared. I'm going to change the signs. And what I get here is 32x squared. So 32x squared, and I'm going to bring down a negative 104x. Okay, so 32 divided by 2 is 16, and we have an x, so positive 16x. Now I multiply, I get 32x squared. 16 times 5 is negative 80x. I change the signs, and when I add, these go away. Negative 104 plus 80 is going to be negative 24x. And I bring down the 60, and I have to keep going until the exponent here is less than the exponent in my d term. So negative 24 divided by 2 is negative 12. I multiply, I get negative 24x plus 60. And you can see that when I subtract, I'm going to get a remainder of 0, which is right because that was a factor. So now f of x is 2x minus 5 times 3x squared plus 16x minus 12. All right, and now I need to factor a little bit more. So I'm going to get 3x and x. And now I need to find two numbers that multiply to 6 and so on and so forth. So if I do 6 over there on the outside, I get 18. And if I make that positive 18 and negative 2 here, I get positive 16. So that's the factored form. And there we go. We just factored that polynomial. Who would have thought? All right, let's do a little bit more long division. All right, so 3x plus 2 And here I have 108 x to the 5 minus 36 x to the 4 plus 75 x squared. Ooh, made a mistake. So look at the exponents here. I have a 5, a 4. I'm missing the 3. So what I do here is I put in a placeholder, 0x cubed plus 75x squared plus 36x plus 24. Okay? All right, so we're going to go ahead and get started. So first we have 108 divided by 3. Okay, so 108x to the 5 divided by this, I'm going to get 36x to the 4. And here I get 108x to the 5, and 36 times 2, this is positive 72x to the 4. When I change the signs, and I need to get rid of this, here I get negative 108 again, x to the 4. Now when I divide, negative 108 divided by 3 is negative 36. This time I get x cubed. So what I have to do though is bring down the 0x cubed. So here I get now negative 108 x to the 4 minus 72x cubed. Change the signs, and I get 72x cubed. Bring down the 75x squared. 72 divided by 3 is 24x squared. So here I get 72x cubed plus 48x squared. I'm going to change the signs. So here I get 75 minus, here I get positive 27x squared. Now the 36 comes down. 27 divided by 3, I get a 9 x. So I get 27x squared plus 18x. And if I change the signs, 36 minus 18 is 24. It's 18x. And I bring down the 24. So finally I multiply by 6. So I get 18x plus 18. And my remainder is a 6. So now the answer here is going to be the quotient plus the remainder over the divisor. Okay, so that's the final answer. All right, in a case like this, here I have x to the 3, 2, 1, 0, so I'm good, and I write that in here. Outside, I have x squared minus 5x plus 6, and the process is the same. First term over the first term, I get an x. When I multiply, I have x cubed minus 5x squared plus 6x. Now I have to change my signs, and I get, these go away, 4x squared minus 20x, and this comes down. So 4x squared over x squared is plus 4, so I get 4x squared minus 20x plus 24. And if I change these signs, then the remainder is negative 4. So that means that the answer is x plus 4 plus negative 4 over x squared minus 5x plus 6. So that doesn't look nice. So we write it as x plus 4 minus 4 over x squared minus 5x plus 6. Now we could have also written this as f of x is equal to x plus 4 times the divisor plus the remainder. So both of these are perfectly acceptable. All right, well, what about synthetic division? Synthetic is the fake kind of division. I call it the tofu of division. It's like tofurkey. And since it's fake, it really only works if you're dividing by a linear factor of the form x minus c, right? So you can't divide something by x squared and so on and so forth. So let me just remind you how to divide synthetically. In this case, again, we have to check for the exponents. So I have 5, 4, 3, 2, 1, 0, so I'm good. Now the thing with synthetic division is, with long division, those variables, x to the 5, x to the 3, and so forth, are really meaningless, and they're just being carried over step after step, and it's tedious. This gets rid of the variables since we're only working on the coefficients anyway. So we write down the coefficients, so 2, negative 4, negative 3, negative 6, negative 5, negative 8. Now, in the front, I'm going to take this divisor, set it equal to 0, and solve for x, and that's the number that goes here. So I move the 2 down. That's for free. The 2 comes down for free. Now, whatever happens to make its way down here below the line gets multiplied by the number out front, in this case, the 3. So the 2 comes down. You multiply by 3, you get 6. We add this way, we get 2. Anything that moves down here gets multiplied by 3, we get 6. We add this way, we get 3. We multiply, we get 9. We add this way, we get 3. We multiply, we get 9. We add vertically, we get 4. We multiply, we get 12. We add vertically, we get 4. Now that last number, no matter what it is always the remainder. Okay, and there we go. We've actually we're done dividing. All right, now the numbers that we get underneath here are going to give us our quotient. We use the coefficients, and what happens is the exponent of that highest degree is reduced by 1 when we divide. So if it was x to the 5, it's now x to the 4. So the coefficients are 2, positive 2, positive 3, positive 3, positive 4. And now, next to these, I'm going to put my variables. So x to the 5 now becomes x to the 4. And from here, it just moves down across from x to the 4 to x to the 3, x to the 2, x to the 1, and finally the constant term. So in our directions, it said to express the result in the form of the quotient plus remainder by divisor. So it's this plus 4 over x minus 3. Now, what happens if you have a term missing? Like in this case, for example, we have x to the 5, 4, 3. The 2 is missing. Then I have a 1 and a 0. Well, same, we're going to have to put a placeholder for that. So my coefficients are going to have a placeholder. Similarly, this sort of tackles two principles at once. What happens here is, since you're multiplying the x by 4, it's 4x plus 1, we have to account for that. So what we have to do is, in this polynomial, divide each term by 4. So this is the number in front of the x. So now my new polynomial becomes 48 divided by 4. So 12x to the 5 plus 7x to the 4 plus 68 divided by 4 plus 11 over 4x plus 3 over 2 divided by 4x plus 1. Now, let's put in the coefficients. Remember, we have to put a 0 where the x squared term should be. So 12, 7, 17, 0, 11 over 4, 3 over 2. All right. And out here, I take my 4x plus 1, my divisor, set it equal to 0, so x is negative 1 over 4. All right, so x is negative 1 over 4. Okay, 12 comes down for free. Multiply this way. So the way I do this is I put diagonal arrows where we need to multiply and vertical arrows where we need to add, so you can refer to that. Now, negative 1 over 4 times 12 is negative 3. You add to get 4. Negative 1/4 times 4 is negative 1. You add, you get 16. 16 times negative 1/4 is negative 4. You add, you get negative 4. Multiply by negative 1/4 to get 1. Now we're going to add 11 over 4 plus 1 over 4 is 15 over 4. All right, we multiply 15 over 4 times negative 1 over 4, and we're going to get negative 15 over 8. And let's just go over here and add that. So negative 15 over 8 plus 3 over 2, if we multiply by 4, is 12 over 8. So that's negative 3 over 8. Now that's the remainder. Okay, so let's write this down. That it's going to be 12, and the exponent is going to be x to the 4 plus 4x cubed, 16x squared, negative 4x plus 15 over 4. Now, minus, it's 3 over 8 divided by 4x plus 1, but that doesn't look good. So we say 3 over 8 times 4x plus 1. And we can barely fit that in there. All right, so that's the answer there. All right, so where is all this getting us? All right, let's talk about two theorems, the remainder and factor theorems. So the remainder theorem says this. If you have a polynomial f of x and you divide it by something, the remainder is f of c. Well, what does that mean? Let's talk about what that means. All right, here I need to find f of negative 2. Okay? We know how we do this. We plug in negative 2 all over here. So let's do that. That's called direct substitution. So it's going to be f of negative 2 is 3 times negative 2 to the 4 minus 8 times negative 2 to the 3 plus 4 times negative 2 squared plus 6 times negative 2 minus 9, and then we do the math, we plug it in, so on and so on. And finally, we realize that f of negative 2 is equal to 107. Okay? Well, okay, so that's fine. It was a little tedious, not so much fun, but there has got to be another way. And oh my God, there is. So look at this. Now let's do it using synthetic substitution. All right, it's just like if we're dividing. So here we have exponents of 4, 3, 2, 1, 0. We're good to go. 3, negative 8, 4, 6, negative 9. And out here we put negative 2. Okay, bring down the 3, multiply negative 6, add negative 14, multiply to 28, add 32, multiply negative 64, add negative 58. Multiply 116, add 107, and oh my gosh, that remainder is f of negative 2. All right, so that's all you have to do. And tomorrow in class, I will show you the proof of this one. Okay, so let's talk about the factor theorem. Now, you already know this, okay? If x minus c is a factor of the polynomial, then when you divide, you get 0. Well, we know that because, like we said, if 8 is a factor of 24, and if I divide, I get a remainder of 0, okay? Now, similarly, suppose x minus c is a factor. If x minus c is a factor, that means that c is one of the zeros. So for example, if I have a polynomial and I factor it and I get x minus 3 times x plus 1 times x minus 2, right? Here, x equals 3 is a 0. Well, if x equals 3 is a 0, and if I plug that 0 into my f, then I need to get 0. So that's what this says. So a polynomial has a factor of x minus c if and only if f of c is 0. What does that mean? If you use the remainder theorem to evaluate f of c and the result is 0, then c is a 0 and x minus c is a factor. So let's see if x minus 5 is a factor of this polynomial. Well, let's do synthetic division. I have 5 out here, and here I have, I think there should be a plus or a minus there, and it looks like it's a minus actually. So I put in my coefficients, 1, negative 2, negative 13, negative 10. So let's see, 1 times 5 is 5, 3, 15, 2, 10, 0. Oh my goodness, this is a factor. All right, let's see if x plus 2 is. So if I put negative 2 here, 1, negative 2, negative 13, negative 10, 1 comes down, times negative 2. You add, you multiply, you add, you multiply, and oh my god, x plus 2 is also a factor. Okay, so big deal. Now what? Well, suppose you're walking down the street and you see this polynomial and somebody taps you on the shoulder and says, hey, negative 1 is a 0 of this equation. So you say, oh my goodness, I could totally use synthetic division and find all the other zeros. So let's go ahead and do that. Now, this is 15x cubed. Then I have to the power of 2, 1, 0, so I'm good. So I know that one of the zeros of this is negative 1. Let's see if I can find any of the other ones. I'm going to divide this synthetically with negative 1. So 15 comes down, negative 15, negative 1, 1, negative 2, 2, 0. Now remember, you must get a 0 here because if negative 1 is a factor, then that has to be 0. The remainder must be 0. Okay, so f of x is now this polynomial. By the way, this polynomial that we get after synthetic division is called a depressed polynomial. So here I'm going to get 15x squared negative x minus 2. So f of x is equal to this times, now if negative 1 is a 0, that means x minus negative 1 is a factor. So x plus 1 is a factor. So f of x is this times x plus 1. Okay? So now, can we factor this? Of course we can. So let's go ahead and do that. So here we get 3x and 5x. And if I put a negative 2 here, the outer part will be negative 6 plus 5x, it's negative x. Okay, so now if f of x is this, and if I set that equal to 0, then x is equal to negative 1 over 3, 2 over 5, and minus 1. How cool was that, guys? All right, one more. Now negative 1 over 3 is a root. So let's go ahead and find this. X to the 3, 2, 1, 0, we're good to go. Negative 1 over 3 goes out here. Okay, 3 comes down. 3 times negative 1 over 3 is minus 1. You add, you get 6. Multiply by negative a third, you get negative 2. You get negative 24 when you add. Multiply by a third, it's 8, but since it's negative, it's positive 8. So here we get 0 for the remainder as expected, meaning f of x is equal to this depressed polynomial times, now, if it's x plus 1 over 3, we don't normally write that like that. We write it as 3x plus 1, right? Because now if you solve this, you get negative 1 over 3 out of it. So 3x plus 1. If I now factor and set this equal to 0, right? Actually, from this, I can factor out a 3. So I get x squared plus 2x minus 8 times 3x plus 1 equal to 0. So here, I have x, and now I need to multiply to get 8, so that's going to be a 4 and a 2, and actually a positive 4 and a negative 2. So x equals negative 4 to negative 1 over 3. All right, last but not least, here we have a polynomial function with a k as one of the coefficients. We need to find the value of k so that the remainder is 0. Okay, so let's just divide. We're going to divide synthetically. My exponents are 3, 2, 1, 0, so I have 1, 18, k, 4. Bring down the 1. Oops. What do we put here? Negative 2, of course. Multiply by negative 2. I get 16. When I multiply, it's negative 32. Now, when I add here, I get k minus 32. Now, when I multiply this by negative 2, I get negative 2k plus 64. Okay? Now, I'm going to add these. So I'm going to get negative 2k plus 68 for the remainder. But what did I want? I want the remainder to be 0. So I want this term to be 0. So I actually take that term, set it equal to 0. So negative 2k is negative 68. K is equal to 34. And look at that. That's the value of k. All right, guys, it's been fun. I'll see you guys in class.